This is Mr. Alexander again, and this is the second video of the Unit 4 test review. We're starting on number 10. Now, on number 10 here, we are going to need to use the quadratic formula, and the reason why is if I was to graph this thing, 81x squared plus 25, I'm looking for the x-intercepts. I'm looking for this where this thing crosses the x-axis. As you can see, there's nothing on the screen, but if I zoom out a little bit, it might show us what's going on here. We still can't see anything. I'm just going to adjust my window. I'll make it pretty small, -10 to +10, and we'll go from 0 to, I don't know, 100. Let's see if we can see it then. There it is. As you can see, this thing never crosses the x-axis, which means that it's going to have complex solutions. To find those complex solutions, we're going to need to use the quadratic formula. And in this case, the quadratic formula, we've got an A of 81, a B of 0, and a C of 25. So I'm going to plug that directly into the quadratic formula. X equals -b, or just 0, plus and minus the square root of b squared, which is just 0, minus 4 times A, which is 81, times C, which is 25. All divided by 2A. Or 2 times 81 is 162. And this looks like some calculator work. So I'm going to do in my calculator, let's see, 4 times 81 times 25 is 8100. So I've got x equals 0 plus and minus anything is just positive and negative. Square root of -8100 all over 162. Let's see, 8100, is that a perfect square root? I don't actually know. Square root of 8100 is 90. Okay, so check it out. We've got, since it's negative, this is going to reduce to 90i, positive and negative, all over 162. Now I can reduce that a little bit if I take a 2 out of the top and out of the bottom. So that's going to be a 45i over 162 divided by 2 is 81, and it looks like I can actually reduce this a little bit more because they both have a 9 in them. So 45 divided by 9, that's just 5i. 81 divided by 9 is 9. So it looks like this is going to be, and I forgot my positive and negative, but there should be a positive and negative. Those are my two solutions, 5i divided by 9, and that's it. That's the answer for number 10. So let's flip over to the second page now, and let's look at number 11, where we're supposed to simplify some complex numbers here. Remember, a complex number is simply the combination of a real number and an imaginary number. And when you see a minus in here, that means we're going to combine like terms. But what I like to do is distribute the minus sign first. So I got 4 plus 4i plus a negative and a negative makes a positive 3, and negative makes a positive 2i. So I just distributed the minus sign and changed it to plus. So now I'm just combining like terms. 4 plus 3 is 7. 4i plus 2i is 6i, which is the answer. Okay, so the next step is this is the same thing. We're going to combine like terms with these two complex numbers. -4 plus 2 is -2, and -3i plus -i is -4i. It's just that simple. The mistake everybody tries to make on these problems is they don't acknowledge the plus sign. They see two sets of parentheses and they try to FOIL it out or use the box method. These are definitely not multiplication problems. These are combine like terms problems, so they're pretty simple. They're supposed to be that easy. Number 13, simplify a square root of -64 plus 5 using the imaginary number I. Well, so would you agree that the square root of -64 is simply the square root of positive 64 times -1? Hopefully you do. We still got that plus 5 out there. Well, the square root of 64 is just 8, and the square root of -1 is I, so I can change this to 8i plus 5. Now, usually in math, it's good etiquette to write the real number first, so I'm going to change that to 5 plus 8i. That's just good etiquette. You write the real number first, then the imaginary number second. Solve. 3x squared equals 192. Now, one method of solving that we haven't talked about, we talked about graphing, we talked about factoring, we talked about quadratic formula. There's another method, and sometimes that's easier to do. Problems like this, just go ahead and solve by using square roots. Start by dividing by 3 on both sides. To get x squared equals, let's see, 192 divided by 3 is 64. So x squared equals 64. And then take the square root of both sides to get x equals positive and negative 8. Sometimes that's the easiest way to do that. Just solving using square roots. Now it's only going to work if there's no x term in there. If you've got an x squared and a c value, but no b value, this sometimes is the easiest way. But if you have a b value, like if this said plus 10x in there, then you're going to have to factor, you're going to have to use the graphing, or you're going to have to use the quadratic formula. What are the solutions to quadratic below? So here, there's no equation, it's just a picture, but check it out. We've got, this thing crosses the x-axis at positive 2, and that's 2, 0, and negative 6, 0. Now all you need to remember is that the solutions to any quadratic are simply where the y equals 0, where it crosses the x-axis. So here, very simple, x equals negative 6 and 2. That's it. That's number 15. Let's move on to number 16, which is a word problem. A rectangular parking lot has a width of 70 feet. I'm going to go ahead and write that on the picture. 70 feet and a length of 30 feet. The owner of the parking lot will expand the lot size by adding x feet and 2x feet to its dimensions as shown below, right here. If the area of the parking lot cannot exceed 10,000 square feet, what is the inequality that can be used to find all possible values of x? Keyword here is square feet and area. We know we're talking about area, so to find the area of a rectangle is simply length times width. Well, the length of this side is 30 plus 2x, and this one is 70 plus x. So if I was to find the area, I'd say, okay, that's 70 plus x is the width, the length is 30 plus 2x, and I know that the area cannot exceed 10,000 feet, which means this thing has to be less than or equal to 10,000 feet. And it says, write the inequality can be used to find all the values for x. Well, that's the inequality right there. It didn't ask us to solve, simply to write an inequality, which is what we've done. All right, number 17 is a good one. For what value of b in the equation x squared plus bx plus 225, for what value of b will this equation have negative 15 as its only 0? Interesting. So remember that a 0 is where this thing crosses the x-axis. And I think the easiest way to solve this is to say, well, if it has a 0 of negative 15, that means that the x equals negative 15, right? Well, if I was to rewrite this in factored form, I'd write that as x plus 15 equals 0. Now, normally we have 2 factors because it's a quadratic. But if it only has 1 0, that means that the factor is simply squared. There's 2 of them, which means that x plus 15 times x plus 15 equals 0. Now, in order to get my equation to look like this equation, I'm going to need to either use the box method or FOIL this thing out. I'm going to FOIL it out, and I'm going to get x squared plus 30x plus 225 equals 0. And now my equation looks an awful lot like that equation, and I know that the value of b must equal 30. All right, we're moving right along here. And let's talk about the last one on this page here, is number 18. The table below shows the values of a quadratic function g. Based on the table, in which intervals can a solution g of x equals 0 be found? So I'm looking at this column right here, and I'm looking for zeros. And I see one's probably going to be right there, and there's another one that's kind of tricky. See how this is going, right here is the highest, and it's going down, 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 down. It looks like at the next one, at x equals -6, there's going to be another 0 right there. So there's two intervals where the solution can be found. One of them, g of x, is between, I'm sorry, I wrote that incorrectly. It should be the x is in between -6 and -5. That's one of them. The other one's right there. X is between 2 and 3. So that's number 18 right there. All right, let's move on to the third page. Number 19 here. Simplify the following. -25 plus and minus the square root of -289 divided by 25. I want to start by looking at the square root of 289. Let's just see if that's a pretty number. And it is, it's 17, which means I can rewrite this thing as -25 plus and minus the square root of 17i divided by 25. Now we could call this fully simplified because 25 doesn't go into 17 at all, but we could rewrite it a little bit as two fractions. We could say -25 over 25 plus and minus 17i over 25, which of course would reduce to -1 plus and minus 17 over 25i. So that's an acceptable answer, and that's an acceptable answer. Either way you want to write, that's fine. Let's write the solution set for x squared plus 8 equals 10x. What we are going to probably need to do here, because this doesn't look factorable to me, is we're going to need to use the quadratic formula in all likelihood. So the first step here is to write it equal to 0, x squared minus 10x plus 8 equals 0. So my a equals 1, my b equals -10, and my c equals 8. So when I plug this thing into the quadratic formula, I'm going to get x equals -b, which is +10, plus and minus the square root of b squared, which is 100, minus 4 times a times c, all over 2a, which is just 2. 4 times 8 is 32. 100 minus 32. Okay, this is the part where we don't want to make mistakes, so we'll just use the calculator, is 68. So this is 10 plus and minus the square root of 68 all over 2. 68, if we're going to reduce that radical, we're going to type that in as 68 divided by x squared. I'm going to scroll down to the first time I see a number less than 1 in the y column, which is right there, and then I'm going to scroll back up to the first time I have a whole number in the x and y column. Square root of 68 is 2 root 17, which means x equals 10 plus and minus 2 root 17, all divided by 2. The last step here is to realize that 10 and 2 are both divisible by 2, so I can rewrite this as 5 plus and minus the square root of 17. That's the answer. All right, 21. It doesn't look like I'm going to have enough time to do number 21, so we'll pick up on number 21 on video number 3. Thank you for watching.